Hi guys, my name's Sean and I got a H1 in Leaving Cert Maths, and in this video we're going to be looking at Axiom 4, which is the conditions for congruent triangles. And just to reiterate what an axiom is just a statement we make in maths that we assume to be true. And congruency in triangles means that if two triangles are congruent, they're identical in every way except where they lie on the page. So we're going to be looking at the conditions for what makes congruent triangles. So the conditions are side, 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 angle, side, and angle, side, angle, and we're going to go through these one by one. So the first condition is if a triangle has the exact same three sides, meaning side lengths, as another triangle, then these two triangles are congruent. So in our case, if we have this side on the left over here on the first triangle equal to this side over here, and I'm just drawing a line through the sides to indicate that they're the same length. And we know that these sides on the bottom and the top over here are the same. And we also know that the longest sides in each triangle are also equal. So we have three lengths here which correspond to one another, and that means that these two triangles are congruent. The second condition is side angle side. So in this case, we're just going to know two of the side lengths and then the angle in between those two sides. So imagine we knew that this was equal to 4 and this down here was equal to 6. And then we had that the angle in here is a right angle. And we could also say the same thing about this triangle over here. So we have 4, 6, and a right angle. That means that these two triangles, once again, are congruent. And so moving on to the last condition now, we're going to look at angle, side, angle. So in this case, it's going to be the same idea essentially as side, angle, side, except we're going to have two angles on the side in between them. So in our first triangle, imagine we knew that this angle down here is equal to 90 degrees. We had that this side beneath that angle, in this case was 10 for instance, and then we knew that this angle was 30 degrees. And let's say we knew the same thing about the triangle on the right, even though it's in a different location and different position, we knew that the same order of angles and sides held. Then we could say that by angle, side, angle, these two triangles are congruent. So you can kind of think of these conditions as the minimum that needs to be true for us to say the two triangles are congruent. If they have three of the same sides, they're identical in every way, and same thing for having two sides and an angle in between, or two angles and a side in between. So that is it for this axiom, and I'll see you next time.